Good morning, viewers. I'm teacher Betty, the chemistry teacher, continuing with the molar concept. Today we are going to look at standard temperature and pressure, or STP, and room temperature and pressure, or RTP. In previous lessons, we have been relating equation, moles and mass. This time we are going to relate equations, moles and volumes. And in this topic, we will look at the volume of gases. It is not convenient to weigh gases. Instead, they are measured in terms of volumes. STP means standard. T stands for temperature. And P for pressure. It was found out that 1 mole of any gas occupies 22.4 liters or 22,400 cubic centimeters. Why? Because 1 liter is equal to 1 cubic decimeter is equal to 1,000 cubic centimeters. I'm only multiplying to come to the value. And this 22.4 liters is known as the molar volume. A mole of any substance is numerically equal to the relative formula mass of that substance. So if we can take the substance as a gas, so this means that 1 mole of oxygen molecule contain 32 grams. How? Because 16 times 2 is equal to 32. Since 1 mole of oxygen occupies 22.4 liters and 1 mole of oxygen weighs 32 grams, therefore 32 grams of oxygen contain 22.4 liters at STP. So we are done with STP. Let us look at RTP. RTP stands for room temperature and pressure. It is also found out that 1 mole of any gas occupies 24 liters, all 24 cubic decimeters, all 24,000 cubic centimeter. Why? The reason is the same. 1 liter is equal to 1 cubic decimeter is equal to 1,000 cubic centimeters. Just multiplying to get the value. What does this mean? It means that if we take a gas to be oxygen, this means that 1 mole of oxygen occupies 24 liters at room temperature and pressure. This 24 liters is called the molar volume at room temperature and pressure. So again, if we relate the mass with the moles, it will be 1 mole of oxygen molecule contain or weighs 32 grams. If 1 mole of oxygen occupies 24 and 1 mole of oxygen contains 32, therefore 32 grams of oxygen contain 24 liters at room temperature and pressure. You just change whatever gas is given. Even though it is carbon dioxide, it will be 1 mole of carbon dioxide molecule contain 24 liters. In terms of masses, 1 mole of carbon dioxide molecule contains 44 grams, the molecular mass of carbon dioxide. Therefore, 44 grams of carbon dioxide contain 24 liters. Let us now look at some examples how to go about with STP and RTP. Example 1. Calculate the mass of magnesium required to produce 2.24 liters of hydrogen at STP on the reaction with dilute sulfuric acid. Usually they remind you what a mole of a gas occupies, either at STP or at room temperature and pressure. If it is not under the question, usually on the first page of the question paper. So for this case, we have to write the reacting equation. Sulfuric acid reacting with magnesium. Properties of acids, they react with the metals to liberate a solute and hydrogen. So we are expecting to get a solute of magnesium sulfate and hydrogen gas. Does our equation balances? Yes. So we go back to the question. Calculate the mass of magnesium. The mass of magnesium, the question mark, required to produce 2.24 liters of hydrogen. 2.24 liters of hydrogen. So we are only going to deal with the magnesium and hydrogen. Remember we said a mole of any gas occupies 22.4 liters. How many moles of hydrogen are we given or have we obtained on the reaction with dilute sulfuric acid? We have obtained only 1 mole. Then you tell the examiner from the equation. From the equation, we have only 1 mole. I told you to begin with a side that is having an answer, but not a question mark. So this is 1 mole. And 1 mole of any gas occupies 22.4 liters. We can say 1 times 22.4 liters of hydrogen was formed or produced by the atomic mass of magnesium. The atomic mass of magnesium is given to us as 24 grams of magnesium. Therefore, what about 2.24 liters of hydrogen will be formed by, we cross multiply 24 times 2.24 liters over 22.4, which is equal to 2.4 grams of magnesium. Therefore 2.24 liters of hydrogen are formed or produced by 2.4 grams of magnesium. Example 2 is obtained from 2015, paper 1, number 40. Aluminium reacts with hydrochloric acid according to the equation. We are given aluminium plus hydrochloric acid to produce hydrogen and aluminium solute. Which one of the following is the volume of hydrogen formed at STP when 5 grams of aluminium is reacted with excess hydrochloric acid? We are given the atomic mass of aluminium is 24 and a mole of any gas occupies 22,400 cubic centimeters at STP. As usual, I told you to rewrite the equation. 2 aluminium reacting with the hydrochloric acid to give us 3 molecules of hydrogen and aluminium solute. We go back to the question. Which one of the following is the volume of hydrogen? The question mark below hydrogen is formed at STP when 5 grams of aluminium reacts with then 5 grams below aluminium. We are only dealing with aluminium and hydrogen. So as usual, you tell the examiner from the equation since we are given mass, so we have to go to the relative formula mass of aluminium. This is the same as 2 times 27 grams of aluminium produce how many moles? There are 3 moles, but we are told each mole of any gas occupies 22,400 cubic centimeters. So times 22,400 cubic centimeter. What about 5 grams of aluminium? Will produce, we cross multiply 3 times 2,400, 322,400 cubic centimeters times 5 over 2 times 27 grams. And our answer would be A. Example 3 is from 2015, paper 2, number 5. A. Soot is a form of carbon. Write an equation for the complete combustion of soot in oxygen. This will be carbon plus oxygen to give us carbon dioxide. Complete combustion, we produce carbon dioxide, and the equation balances. B. Calculate the volume of the gas at room temperature when 0.6 grams of soot is burnt in excess oxygen. So we write 0.6 under soot, which is carbon, and the volume of the gas produced, the question mark. The volume of the gas will be carbon dioxide. Again, I told you, you go direct from the equation. What do we have in the equation? We are given mass, we go to the atomic mass or molecular mass of a given compound. This time we have the atomic mass of carbon. The atomic mass of carbon is given to us as 12. So 12 grams of carbon produces, they want the volume. We look at the moles in effluent. There is only 1 mole, and we said a mole of any gas at room temperature occupies 24 cubic decimeter. So 24 grams of carbon produces 1 times 24 cubic decimeters of carbon dioxide. What about 0.6 grams of carbon will produce? We cross multiply 24 times 0.6 over 12, which is equal to 1.2 cubic decimeters of carbon dioxide. Roman number 3, deduce the volume of the gas that will be produced at room temperature if the same mass of graphite was burnt in excess oxygen. Maybe to remind you, soot is an allotrope of carbon. Carbon exists in 3 different forms. We have graphite, diamond, and amorphous carbon. An example of amorphous carbon is soot. So graphite is also carbon. If we burn graphite, an equivalent mass of soot in excess oxygen, we are going to get the same volume of carbon dioxide at room temperature. Therefore, Roman number 3, the answer will be 1.2 cubic decimeters of carbon dioxide. Give reasons for your answer. The answer is already given to you. I have already discussed that equal masses of given allotropes under the same condition will produce the same product. Like graphite is burnt in the same condition as soot, so we expect to get the same volume of carbon dioxide.
kuki tuli mu basi mulagawa tawuni kyanaku kikabya okabya kivo kya digito muzekwa nalogo. Eno basi tekyalina mataala, eno basi tekyalina mipiira, eno basi indiketa za ndali. Mugive mangu temufiiramu, ne gye mulaga teriyo mulamwa, kujjako okugwa mu binnya n'okufiira mu njaga. Mubeesige yasigaza bigambo, mayimayi azunga buzungu. Muli kuki tuli mu basi mulagawa tawuni kyanaku kikabya okabya kivo kya digito muzekwa nalogo. Mwasomako twasoma luzungu kati mukolawa tuli ku street. Mulya biki? Tulya mandazi. Musulirira ki? Tusulirira pani kyanaku. Muli kuki tuli mu basi mulagawa tawuni kyanaku kikabya okabya kivo kya digito muzekwa nalogo. Kituuka katako tuteekwa buteekwa, kituuka katako tusaana kukyusa. Twenda pulezidenti mulala, twagala musomesa, twagala dokita bosa science, atuwe vaccine, atuwe treatment, atuwe solution. Akitegedde tegeeza omulala, atategedde tokoppa bukoppi kyanaku. Muli kuki tuli mu basi mulagawa tawuni kyanaku kikabya okabya kivo kya digito muzekwa nalogo.
Another example is obtained from 2014, paper 1 number 37. Sodium hydrogen carbonate decomposes according to the equation, where sodium hydrogen carbonate produces sodium carbonate, carbon dioxide and water. The mass of sodium hydrogen carbonate, which must be heated to give off 200 cubic centimeters of carbon dioxide at room temperature. 1 mole of a gas occupies 24,000 cubic centimeter, and we are given the atomic masses of sodium, carbon and hydrogen. So rewrite the equation as usual. Sodium hydrogen carbonate producing sodium carbonate plus carbon dioxide plus water. So back to the equation, the mass of sodium hydrogen carbonate, equation mark, which must be heated to give off 200 cubic centimeters of carbon dioxide. 200 cubic centimeters of carbon dioxide. All along they have been giving us mass and we are looking for the volume. This time we are given the volume and we have to look for the mass. So I begin with the side with an answer but not the question mark. The moment they have asked us the mass, we go direct to the molecular mass of a given compound. So RFM of sodium hydrogen carbonate, this is the same as 2 sodium plus hydrogen plus carbon plus 3 molecules of oxygen, which is 2, 23 plus 1 plus 12 plus 16 times 3, and the answer is 84 times 2. So from the equation, we have only 1 mole of carbon dioxide, and we are told that each mole of a gas occupies 24,000 cubic centimeters. So 1 times 24 cubic centimeters of carbon dioxide was formed or produced by what I got from the equation, 84 times 2 grams. Therefore, 200 cubic centimeters of carbon dioxide will be formed by, we cross multiply 84 times 2 times 200 over 24,000 cubic centimeter. So this is the answer, and our answer is A. Another example is obtained from 2013, paper 1 number 21. Propane burns in air according to the following equation. Propane plus oxygen to give us carbon dioxide and water. Which one of the following is the volume of air required for complete combustion of 60 cubic centimeters of propane? So we have to rewrite our equation. Propane plus oxygen to give us carbon dioxide and water. Back to the question, which one of the following is the volume of air required for complete combustion of 600 cubic centimeters of propane? The percentage of oxygen in air is 21% by volume. Let us first get the volume of oxygen used, then we shall get the amount of air required. We are told 60 cubic centimeters. We are interested in the volume of oxygen used for complete combustion. So from the equation, one mole of propane reacted with 5 moles of oxygen. What about 60 cubic centimeters? You can wonder why I'm using cubic centimeters, yet I have moles. So either way, if I multiply by 1 mole of a gas and by 1 mole of a gas, that value will cancel. So even though I use the moles, the answer will be the same. So therefore, 60 cubic centimeters of propane will react. I cross multiply 5 times 60 over 1. So that is the cubic centimeters of oxygen used for complete combustion. So we have to go and find out the volume of air used that contained this much. We are told the percentage of oxygen in air is only 21%. So 21 cubic centimeters of oxygen is contained in or is found in 100 cubic centimeters of the air. Therefore, 5 times 60 cubic centimeters of oxygen will contain or will be obtained from how much air? I cross multiply at 100 times 5 times 60 over 21 cubic centimeters. So this is the amount of air that will contain this volume of oxygen used for complete combustion. And the answer is C. The last example is obtained from 2012, paper 1 number 20. When 150 cubic centimeters of oxygen was mixed with the 500 cubic centimeters of hydrogen and the mixture exploded, water was formed according to the following equation. Hydrogen, oxygen to produce water. The volume of hydrogen that was left unreacted is, let us rewrite the equation as usual. 2 hydrogen plus oxygen to produce 2 moles of water. Back to the question. When 150 cubic centimeters of oxygen, 150 cubic centimeters of oxygen was mixed with 500 cubic centimeters of hydrogen, 500 cubic centimeters of hydrogen, and the question requires us to find the volume of hydrogen that was left unreacted. So for such questions, you have to get the volume of hydrogen that reacted with 150 cubic centimeters of oxygen, after which we subtract to get the one which did not react. Let us calculate together from the equation. One mole of oxygen react with 2 moles of hydrogen. What about 150 cubic centimeters of oxygen will react with, we cross multiply 2 times 150 over 1, which is equal to 300 cubic centimeters of hydrogen. So this is the only amount of hydrogen that reacted, but mind you, they mixed 500 cubic centimeters of hydrogen. So the unreacted one we obtained it by subtracting 300 cubic centimeters from 500 cubic centimeters. So 500 cubic centimeters minus 300 cubic centimeters, which is equal to 200 cubic centimeters that remained unreacted. The answer is B. So find more activities on the website of dictoteachers.co.ug.